Hello everybody. So this is the week 12 lecture 1 video. So if you look at week 12, you'll see that it says lecture 1 is just going to be method exercises in chapter 12. And that is because if you go back to last week, week 11 here, you will see that lecture 2 last week was on methods, and that actually covers the end of week 11, but also the beginning of week 12. So if I go here, back to week 12, and we navigate to the Zybooks for chapter 12, you'll see that we don't need any new lecture material. It's perfectly fine just to jump in and do exercises. There's nothing new there. Okay, so let us load the Zybooks and we'll go ahead and get started. So I'm not going to do all of these exercises, that's for you to do. But in chapter 12, um, we have methods. And so you have to be used to the concepts of things like, if we're looking at a method right here, you need to know that we're going to be starting writing them with public static for now. You need to know that the third word, in this case, double, is the return type. You need to understand what that means. Like if you're returning a double, that means at the end of your method or somewhere in your method, you need to return a double. If you say you're going to return a double, you have the name of the method. And then in parentheses, you put any kind of inputs to the method. So this is a formula for calculating something. And in order for it to do it, it needs an integer called height feet, and it needs an integer called height inches. Um, and so we're going to be writing these in this section. And so I'll skip through a lot of this and go down to, I guess, are we writing one here? Yeah, let's do this one. So this is not an exercise, right? When it says XIDE, that's not a challenge exercise and it's not a participation exercise, which means you don't have to do it for points. But we'll go ahead and do this one. So it says complete the program by writing and calling a method that converts temperature from Celsius into Fahrenheit using the formula. And this is a good way to kind of explain what we're doing here. So first of all, we're writing a method. Where does a method go? Well, as we learned last time, method needs to go inside of a class. So here's a class, public class, Celsius to Fahrenheit. So that's the name of the class. That's like the name of your project when we make something in Eclipse. Then in here, we want to create a method. Now, main is always there. That's, well, not always, but for us, for now, it's always been there. But it's just a method. So if we're making a new method, we would want it alongside of the main. It could technically be written before the main or after the main, but it can't be inside the main. So if we're going to write a method here, we'll write public static. We don't know really why we're doing that at the moment, but we can write it. Then here comes the return type. So they'll usually give us some information. Looking at this, they did not, but if we're going to be calculating Fahrenheit from Celsius, then those are probably going to be doubles, right? Because you can have something like 98.5 degrees, right? You can have 33 and a third degrees, whatever you have. So it should be a double, not an integer. So if we're going to be dealing with doubles, then I probably will need to return my answer as a double. So we'll put double there, right? So public static double, and then we need the name of our method. Now, I believe that they do not actually force us to name it anything, right? They didn't tell us what to name this method, so it's up to us. So if we're trying to convert Celsius into Fahrenheit, it makes sense to call your function like C to F or C to F or Celsius to Fahrenheit, something like that. So you give it a name. So we'll call it Celsius to Fahrenheit. And then any inputs to this method come in parentheses now. And so the way this is going to work, if we're trying to convert Celsius into Fahrenheit, is the user is going to put in the Celsius. So they're going to put in the Celsius in here, and we're going to calculate the Fahrenheit. So you go ahead and say public static double Celsius to Fahrenheit, and then double Celsius. I've got the closing parentheses there, open curly braces, close the curly braces at the end, and then in here, we just need to do our calculation. So there's a lot of ways to do this. One way would be to say double, let's just call it F because I'm lazy. And then we could put in our formula for Fahrenheit. So the formula for calculating Fahrenheit is 9/5 times Celsius. So if we're dealing with doubles, that should be 9/5 like that, 9 divided by 5. And then times the Celsius, which I called my Celsius like this, all lowercase. So 9/5 times Celsius plus 32. So plus 32. I'll write 32.0 because we are dealing with doubles. And that will calculate the Fahrenheit, right? But we also need to return it because that is how methods work. So if I want to make sure that the answer gets back to where the caller is, I have to return, in this case, the F. Now, this could have been combined into one line, and I'm sure we'll do that later for other functions, but for now, this is fine. So how does this work? Celsius comes in. We calculate Fahrenheit using that Celsius value, and then we return our answer, which I just called capital F for some reason. And to double check, right, we can run it and with this input. Actually, we haven't finished. Sorry. We wrote this method. If I run it now, nothing happens. We're going to get like an error, I think, or we're going to get 0 actually, because it says temp F equals 0. So when you write your method, that doesn't mean your method runs. In order to run it, you have to go down to your main method and make sure you actually execute your function. So our function was called Celsius to Fahrenheit, right? And I can see where I'm supposed to be computing it if I read carefully, right? So there's variables for Fahrenheit and Celsius on lines 13 and 14. Then it says system.out print line, enter a temperature in Celsius, and then temp C equals SC in our next double. So the user is typing in a number. That's what this number is going to be. And then it says temp F equals 0.0, fix me, right? And the fact that it's 0.0 is why it says Fahrenheit 0 here. What we need to do is get rid of that and put in our calculation. So the name of our method was Celsius to Fahrenheit. And into that, we need to provide the temperature in Celsius, which is temp C. So we go ahead and put temp C there. And now temp C is going to go into the method as Celsius. We will calculate the Fahrenheit and return it. And then whatever is returned is going to be stored in the temporary F, or not temporary, temp F variable. So as soon as we do this, we should run it and we should get the correct answer now. For 100 Celsius is 212 in Fahrenheit. And you can try other things here, right? Like what is this is Celsius to Fahrenheit. So like 45 degrees. What is that? 113. Right. So 45 degrees Celsius is 113 Fahrenheit, and we calculated it there. So, yeah. So we'll do maybe one or two of these before we move on of the participation activities here. So if we have a double square root double X, like that line right there is telling you that we have a method called square root. That's the name of it. The input is a double that we're going to call X, and we return a double. So a double comes into the square root function and a double comes out of the square root function. So if you were to type in y equals square root 49, that would be perfectly valid. The 49 goes into the square root. We calculate the square root, probably 7, and then we store the result in y. So that's perfectly fine. This way of writing it doesn't make sense because square root 49 is 7. So this is saying like 7 equals z, but you can't do that, right? When you are writing stuff in Java, if you are assigning a value to a variable, the variable goes on the left like this. The variable does not go on the right like this. So this is invalid. Could this work? Sure. Square root 144 is going to be 12, and then 1 plus 12 is going to be 13, and then that result is going to be stored in y. Perfectly fine. Square root 16. Can you square root a square root of 16? Sure. Why not? Square root parentheses. Nope. Can't do that. Right? The square root function needs a number to square root. You can't just do a square root of nothing. So that won't work. Can you say square root 9 with nothing on the left? Yeah. Y equals print val 9. So what's print val? We haven't looked at it. So this is print val. So print val takes a double for its parameter and it returns nothing. That's what void means. So if it returns nothing, then print val 9 returns nothing. Can we assign nothing to y? Probably not. Could you do print val 9? Yes, because print val, you can put a number into print val, but no number comes out of print val. So you could do print val 9, that probably just prints 9. Okay, so going down to the exercises then, I guess I did 1 and 3. That's probably for my other class. Let's start with 2. Doesn't really matter which one we start with, right? So I'll do number 2. Let's see what this says. So define a method, convert to liters. So that means you're going to write public, static. I need to know the return type. So we read a little more. Define a method, convert to liters that has 2 integer parameters. Those are the inputs. The method returns a double as the volume. So the method returns a double. So public static double. Then we put the name. So the name of the method is convert to liters. So I'll just copy paste it. Convert to liters. Then it says 2 integer parameters for number of gallons and quarts. So 2 integer parameters. So the variable names are decided by us. So I can say int, and for gallons, I can just say GAL if I want. And then another integer parameter that's quarts, and I could say quarts. I could have just used G and Q. I could have written out the word gallons. It's just up to me as the person who's writing this. Okay. So I've got my method. Now, what do we need to do? Well, it says the method returns a double, okay, as the volume converted into liters. Given that a quart is 0.946353 liters, um, and a gallon is 4 quarts. So how do we do this? We need to get liters, right? So I'm going to need a double for liters. First of all, I'm going to do some calculation, and it says the method returns the volume converted to liters. So at the very bottom here, when I'm done, I'm going to say return liters. And then in here, I need to just actually do the calculation, which maybe I'll just do it on this line. Double liters. All right, how do we do it? Well, it says here that 1 gallon is 4 quarts, right? So if I were to, uh-oh, hold on. So the number of quarts that we have is going to be equal to, first of all, the number of quarts that are input, right? So imagine, okay, this is a good example here. So if they put in 154, what they're saying is that there's 1 gallon and there's 54 quarts, right? Because they have two numbers here, 1 and 54, and we have two variables, gallon and quarts. Okay? So the 1 is the gallons and the 54 is the quarts. So if I want to know how many quarts total I have, well, I have, first of all, if they do 154, the 54 quarts is 54 quarts. So the number of quarts is going to be that. Plus, in order to figure out the gallons, they tell us that 1 gallon is equal to 4 quarts. So if I take the number of gallons and I multiply it by 4, then that's also going to give me a number of quarts. So, for example, if you had 1 and 54, the 1 gallon here is 4 quarts, and you would add that to the 54 quarts you already had, and you would have 58 quarts. That's what we're doing. So it's the number of quarts, 54, plus the number of gallons, 1 times 4, because there's 4 quarts per gallon. Cool. So this is going to give me the total number of quarts. That's what that does. And then I need to compute number of liters. And that's what the other formula is. So 1 quart is 0.946353 liters. So what you have to do is take the number of quarts and multiply it by that 0.946353. And with conversion factors, either you're going to be multiplying by that conversion factor or you're going to be dividing that by that conversion factor. And yeah, you can think about it real hard and get the answer right, but you could also just take a guess, run your code. If you get the wrong answer, then come back and fix it. So like if we don't get 54.888, then we'll go figure out what we did wrong up there with the conversion factor. But it turns out that we got it right. So we figured out the total number of quarts, changed that into liters, and then we returned the number of liters. And that was it. We didn't have to call our method because if you look in the main method, they already ran it for us with convert to liters, gallons, quarts. Okay. So that was one exercise. I'm going to do another one. Maybe we'll do number 1 because it'll be easier. I'm going to reload it because it annoys me that it was still gallons and quarts. Okay, let's look at this one. Complete the method grams to ounces. They already wrote some of it for us here. It says one integer parameter as mass. So there it is. One integer parameter that is grams. And then it says the number or the method returns a double. So I can see that here. Method returns a double. And it says we're just going to convert grams to ounces. So you can just use a single return statement, or you can make a variable. So like I can do double, we're converting to ounces. So ounces equals. And how are we going to convert it? Well, like if you put in 117 grams, then you would take that 117, multiply it by the conversion factor up here, that 1 gram is 0.035 ounces. So 117 times that number that's highlighted. And apparently the result is 4.127. So what do you do for the conversion? You take the number of grams, which is called user grams, you multiply it by the conversion factor, which we could just type in, but they put it in a variable, right? So they put it in this variable grams to ounces. So I can just copy it there. And that should be it. So at that point, I just need to return the answer, which is ounces. Okay. Now I'm going to do this and then I'm going to make a small modification. All right. So that worked. Now the modification I'm going to make is simply this. So I have a line here that calculates the number of ounces, and then I return the number of ounces because that's the answer. But this didn't need to be two lines. I could have skipped the variable completely and just wrote return user grams times grams to ounces. And that's the same calculation, right? I just don't have a variable that's called ounces anymore. So it's a little bit harder to understand, but you can make your method shorter this way if you want. So if I hit check, it's still going to be correct, I assume. Okay, so that was like a 12.2. The later sections in here are not really introducing any new concepts. So they are very simply just making you write more methods. So this is just practice. So like this is methods with branches. Branches are if statements. So we're just going to be putting if statements in our methods. There's no big deal. Okay, so I'm going to skip kind of the explanation here and we'll go down here and try to do one of these challenge activities, 12.3.1, but we'll do part two just because. And we're typing the program output. Okay. So what do we have to do? We're trying to type the program output. So there's a big method up here, right? Called calculate cost. But when you start up your program, you don't start in that method, you start in the main, right? You always start in the main. So looking at main, I see cost returned equals calculate cost 35, comma 7. Right? So we need to figure out what calculate cost 35, comma 7 is going to be. So two variables are going into this method, 35 and 7. So you come up here and we have age and units. So let me, I just need somewhere to type. I'm just going to use this programming editor here for this um, to type. So we're calling calculate cost 35, comma 7. So the 35, comma 7 are going in for the variables age and units. So we've got that the age is going to be 35, and we're going to have that the units is going to be 7, right? So 35, 7, 35, 7. Okay. And we're also going to try to figure out a cost, but let's see what we have. So the first if statement here, right? Remember this, the section we're in is called methods with branches. The first if statement here says if age is greater than or equal to 15, which it is, because age is 35. So age greater than 15 is true, and age is less than 29. Oh, that's false, right? So this whole statement here is false, right? We're not greater than 15 and less than 29. So that didn't happen. So we're going to skip all this. Everything highlighted is skipped, and we go down to the else. And the else says, if the units is less than 3, what's units? Units is 7. So units is not less than 3. So we're going to go to the else here. And this one says cost equals, and it says units minus 2, right? So I'm just going to type it out. Units is 7. So that's going to be 7 minus 2. And then it's going to be times 300 and then plus 500. Okay. So if you were to take this number here, work it out. I mean, of course, nothing stops you from just doing this in your head or pocket calculator or whatever. But so 7 minus 2 is 5. 5 times 300 is 1500, plus 500 is 2000. So we get 2000 there. So after we trace through this entire thing, the cost is going to be calculated to be 2000. And that is what's going to be returned on the next line. And so the calculated cost is 2000, and then it prints out 2000. So this should just be 2000, and then we hit enter. And we got it. Okay. So no, there's no new concepts here at all. We had to figure out what happens in the if statements, but we've done that in previous sections. So the only thing that's new was the method. All right, we may as well do this one. So this one, we're kind of writing a function or a method, but we're just doing it by dragging everything over. So it says, organize the lines of code to define a method called print popcorn time. Okay, so, okay, they already wrote the top for us, right? Public static void print popcorn time. So this dashed line here, that's where everything's going to go. It says integer parameter bag ounces. There it is. And void return type. There it is. All right. So then we need to put in our code. So this is where we just read what it says. So it says if bag ounces less than 2. So look for bag ounces less than 2. Here it is. And that goes inside the method. Should be indented one level. So there. What do we do if bag ounces is less than 2? We print too small. So we find that, print too small. That goes there. Now, after we do that, we need to close this with curly brace. So find a closing curly brace to put there. All right. Then it says, if greater than 10, print too large. So we don't have another if statement. We'll have to continue with the else if because that's all we got here. So we have an else if to continue this on. So it says if greater than 10, so if bag ounce is greater than 10, we print too large. So we find print too large, put that in. We'll need a closing curly brace now. Then it says otherwise. We know that otherwise means else. It says compute and print 6 times bag ounces followed by seconds. Well, that's obviously this. And to finish off the else, we'll need the last curly brace. And there you go. That should be correct. We'll run it and see. And it worked. So everything is good. So we got to write some code now. Let's look at number 2. Ooh, look at that. That's a lot of stuff. But this is probably worthwhile to do then, since some of you probably have the same one. Probably every time I click on it, right, the numbers are all changing. So I can't guarantee the same numbers as any particular person. But let's do priority tasks. I don't know. They had a lot of different options here from clicking on it. All right, let's see what we have. Define a method called find resources that takes 2 integer parameters. All right, so find resources that takes 2 integer parameters. Well, it's going to be a public static to start with. We need to know the return type. So let's read up here. It says the number of people is returned as follows. Um, oh, it says returns the number of people required. So I think that's an integer, right? Everything looks like an integer here. So we'll say we're going to return an int. Then we need the name of the method. So the name of the method is find resources. So I'll put find resources. It says the 2 integer parameters are priority and number of project tasks. So priority and tasks. Actually, that's what they called them down here too. So we have two integer parameters. It says, oh, actually, it says here, I didn't read the rest of this, but return the number of people required as an integer. So I didn't read the word integer there, but that's correct for the return type. Now it says two integer parameters, priority and tasks. So in here, we'll go int priority, comma, int tasks. Open curly braces, close curly braces to give myself a place to write our method. So these are the variables, priority and tasks. We look over here and we have to get the right box for all these cases. So there's several different priorities. And then for each priority, there's three different ranges for the tasks. So there's actually going to be 9 possibilities here. Now, how you write this, there's going to be um, a lot of ways to do this. So I guess one way, and I'm not saying this is easier, but this is how I'm going to do it. We need to make our decision based on priority and number of tasks. So I could say if, and let's do priority first. Priority. So if the priority is 1, we're going to do something. Okay. And I'm going to open up curly braces and close them, but I'm just going to leave this blank now. Okay. I don't know why I put a comment in there. Another possibility is that the priority is going to be 2. So that would be an else if priority equals 2. And we're going to put code there. Third choice, another else if is going to be if the priority equals 3. Oops. And then finally, I saw here it says if that the priority is not in the table, return 11. So my else here could be return 11. We can just write that right now because there's no calculation there. So we're going to be doing one thing if the priority is 1, one thing if the priority is 2, one thing if the priority is 3. And if we have anything else for priority, then we're going to return 11 because it said so. Cool. Now, what do we have to do? In each of these categories, there's actually 3 possibilities, right? When there's priority 1, there's still 3 possible answers. And for priority 2, 3 possible answers. And for priority 3, 3 possible answers. So in each of these sections, you're going to also have 3 possible things. So we're going to need more if statements in our if statements. So if priority 1, that's the entire top row. And we have if we have less than 60 tasks. So you'd go if tasks less than 60, then our answer is 60. So I can just do return 60. We could also have tasks between 60 and 139. So I could use an else if there, else if uh, tasks. Well, this is tasks from 60 up to 139. You could just do tasks less than or equal to 139 like this. And in that case, we should be returning 70. And the third possibility is just greater than or equal to 140. But here's the thing. we have tasks less than 60, return 60. We have else if tasks less than 139, return 70. You do not have to say something like this, tasks greater than or equal to 60 to correspond to this. Oops. Why did I not type in the right place? Like what I just did by changing that tasks greater than or equal to 60 and tasks less than or equal to 139 for that middle one, that's fine. But this is actually redundant information because we already know that we're greater than or equal to 60 because if you're in this section of code, you've already checked if the tasks are less than 60. So to even get to the highlighted code, you're not less than 60, which means you're greater than or equal to 60. So this does not need to be checked, but you could, and it's not going to cause an issue. Same thing for the last possibility where we're greater than 140. You could do else if, and then say tasks greater than equal 140. Um, and then say return, I guess it would be 75, like that. That's perfectly fine. But the way this is all written now is the kind of more convoluted way. Like I said, this is redundant because you have to be greater than or equal to 60 to even get to this line of code. So that we don't need that. Also, if we have tasks less than 60, tasks less than or equal to 139, and then a third block of code, well, in order to get to the third block of code, you're automatically 140 or up because we've already taken care of everything that was less than 140. So this is perfectly fine, but it's also not needed. You could just change it to an else because you can only get there if you are greater than or equal to 140. Now, it was fine the way it was. So if you want to write it, then write it the way that I just had it. Um, and how now that I've done it, this highlighted code here, that corresponds to the top row, right? 60, 70, 75, 60, 70, 75. And I can copy that entire if statement and paste it into priority two now. And that'll be the second row. So the second row is supposed to be 40, 50, 55. So you just change the numbers in each if statement to 40, 50, 55. And the same thing for the bottom row, 25, 30, 35. That's going to be for priority three. So you go to priority three, fix the indenting. And we have 25 for our first return, 30 for our second return, and 35 for our third return. And that's a lot of code, but there's 9 possibilities plus an extra, so 10 possibilities altogether. And so that's quite a few lines of code. So pause it if you have the same one and you need to look at it. Otherwise, we'll hit check and it should just be fine. And it is. Okay. And so they just checked it with a bunch of different numbers. Cool. We'll go methods with loops. I'm going to jump down to challenge activity here. We'll do at least one of these. Again, there's nothing new conceptually in here. This is just writing methods, which we learned last week, and putting a loop in it. Of course, you can put a loop in your method. Why not? So if I look at this code here, 12.4.1, and we're typing the program output, let's see what we're doing here. So this is going to be calling, again, go to the main. Don't go to the compute method. We know that when you start your program, you go to main. So you go to main, int value 1, int value 2, int computed value. Okay. Value 1 is 3, value 2 is 1. And then we're doing this. So we're doing compute value one, value two. But we know that value one is three. So we're putting a three in for value one, and value two is one. So we're putting a one in for value two. So what we're actually running is compute 3 comma 1. So with that said, now let's try to figure out what compute does. So the other method up here is called compute. Put it like this. So we have a result I. The two values are called val1 and val2 here. Um, Result is 0. I guess I better put this in. And we have I equals 0, I less than val1. What are these? Val1 is going to be the first entry, which is 3. So val1 is 3. Val2 is the second entry, so it's 1. And we got this loop here. So the loop starts out at 0. So the loop starts at I equals 0. I see that. And goes up to what value? It goes up to, well, it says I less than val1. So it's not going to go up to 3 because that would be equal to val1. It's less than val1. So it's going to be up to 2, right? 1 less than val1. So I goes from 0 up to 2, right? So it's going to go I equals 0, I equals 1, I equals 2. So we're going to go through that loop 3 times. And uh, in that loop, it does result minus equals val2 times 2. So for the I equals 0 iteration of the loop, we're going to take the result. This is the result here. Minus equals val2 times 2. So val2 is 1. So val2 is 1. And result minus equals means we're going to be subtracting whatever number we get over here from the result. So result equals, well, minus equals 2, right? 1 times 2 is 2. So we're subtracting 2 from the result. So result is going to equal -2 after this, because we're going to do result minus equals 2, and it's starting out at 0. So we subtract 2, we get -2. So now we have -2 for the result. The next iteration of the loop, we're going to be running the same line. So we're going to do result minus equals val2 times 2. The val2 is still 1. So we're still going to take the result and subtract 2. So if the result was previously -2 and we subtract 2 more, we're going to be at -4. And then we move on to the next iteration of the loop, which I believe is going to be the same thing happening, right? So we're going to do result minus equals 1 times 2. So we're going to subtract 2 from the result. So the result is going to end up at -6, it seems like. So we're going to go through that loop 3 times. We're subtracting 2 every time through the loop. So we go -2, -4, -6 for the result. And then at the very end, we return the result, which is -6. So compute here is going to return a -6. So we're going to store a -6 in the computed value, and then we're supposed to print it out. So we print out -6, and we got it right. Okay. Next one, more loops. It's going to be a little bit tricky. So when you have something like this, it's good to try to figure out what is the point of the loop. So in here, it says num count equals 6. Cool. print selected numbers num count. So we're putting in print selected numbers 6. So you come up to your method here. We're inputting a 6. So the num count is going to be 6. Let's try to remember that. Num count is 6. We set up a scanner and everything. And then it goes I equals 0, I less than num count. So in this one, I is going to be going from 0 up to it goes less than num count, which is 6. So it's going to be up to 5 is going to be the last entry. So that means our loop is going to be I equals 0, I equals 1, I equals 2, I equals 3, I equals 4, I equals 5. So 6 times through the loop, actually, but the last time through the loop, I is 5. And then what is this loop doing? We're reading a number from the keyboard. So that's these numbers. And if the number modulo 3 equals 0, we print out the number. So you have to understand this code. Um, so I'm actually not going to use that I wrote, but if we're looking at this loop right here, not loop, if we're looking at this code right here, what this code is doing, and you should understand this, is if the number is divisible by 3, that's what this is checking, right? Because number modulo 3 gets the remainder when you divide by 3, and we're seeing if the remainder is 0. So if the number is divisible by 3, then we print it. Okay, so that's what that code does. If the number is divisible by 3, we print it. And we're doing that 5 times through the loop. Okay, so we're going to read a number from the list. And if it's divisible by 3, we're going to print it. So with that in mind, we're going to read 5 numbers starting at I equals 0. So when I is 0, we read 8. Is it divisible by 3? No, so no output. Then we do 15. So that's going to be I equals 1. Is 15 divisible by 3? Yes. So we print it. Whoa. Why did I type that? So we print it. So we go I equals 0, 1, 2, 3, 4, 5. So we're going to do all of these. And if they're divisible by 3, we print them. So 15 divisible by 3, so we printed it. 17, not divisible by 3, so nothing. 9 is divisible by 3, so we print it. 3 is divisible by 3, so we print it. 7 is not divisible by 3, so we don't print it. So we're looping through these numbers and checking if they're divisible by 3 and then printing them. So we're just going to get this, the numbers that are divisible by 3. There we go. And you can see that they explained exactly what I did, and we got the answer correct. Let's write some code. So let's just hit start and do the first one. So define a method output vals, 2 integer parameters, and outputs all the integers. Output vals should not return any value. So no return type. So what do? We go public, static, void. Void because they say we don't return any values. The name of the method is output vals. So output vals. 2 integer parameters. It didn't say what to call them. So I'm going to call them A and B. You can call them num1 and num2, whatever you want. But I called them A and B. Now it says outputs all integers, starting with the first integer, ending with the second, each multiplied by 1,000. So if you do 1 and 4, it goes 1,000, 2,000, 3,000, 4,000. Okay, that's really easy. So Basically, if we had 1 and 4, we need to loop from 1 to 4, right? So that's going to be a for loop. So you just go for int I equals, and we want to start at the first value. So like when it's a 1, we want to start at 1. If it was something else, we would start at that. And then we want to go while I is less than or equal to the second value, which is b, and then I plus plus. Okay. So with a 1 and a 4, this would loop from 1 to 4. Okay. Now, what we need to do in our loop is print the number, but not just the number. We need to print the number and multiply it by 1,000. So that should just be a system.out.println, and the number we're printing would be the I, and we should multiply it by 1,000. So we'll loop 1, 2, 3, 4, but we'll print 1,000, 2,000, 3,000, 4,000. I think that's it. That's everything they said to do. And we got it. So when they did 1, 4, we add 1,000 up to 4,000. They do 2, 4, that's 2,000, 3,000, 4,000. If they do negative 1, 1, it's negative 1,000, 0,000, and 1,000, and so on. All right, cool, worked. Um, let's do number 3. All right. Define a method, find smallest value. Okay. Method. Scanner parameter. Okay. So they didn't really explain this to us very much yet. They will in a later section. But when you're reading, if you need to read from the keyboard in your method, it is better to pass the scanner in as a variable like we just did here. All right. Now, I also didn't write the beginning of this method. So it says, they didn't say anything here, right? It says define a method, which we did. It says reads integers from input until a positive integer is read. And then it says find smallest value should return the lowest of the integers. So if we're returning the lowest of the integers, we are returning an integer, right? So we should start this with public static int, right? Because we're returning the integer that we find. Okay, so we're passing in the scanner object, which is weird, but that's actually a good reason to do it that way. You could have declared the scanner inside of the method and everything would have been okay, probably, but they didn't. All right. Now, what's it say? Scanner parameter that reads integers from input until a positive integer is read. So what we need to do here, this is similar to what we've done before when we're not dealing with methods. But let's just read in our numbers, okay? So I'm going to have a variable called number, okay? And we're going to read the number from the keyboard, okay? So how do I read it from the keyboard? scnr dot next int, right? That's how you read a number from the keyboard. So I'm going to read that number from the keyboard, but then I need to do something. It says we're supposed to keep reading integers from input until a positive number is read. So that's a while loop. So as long as the number is less than or equal to 0, we keep reading numbers or we keep doing things. Okay. Um, so while the number is less than 0, we keep going. And that way, when we read a positive number, that's what makes us stop. Now, in order to make this loop function, we're going to also need to read a number inside the loop. So we're going to read one number to get us started. And then this while loop will keep reading numbers until we end up with a number that's greater than 0. Okay. So number greater than 0 stops the whole process. So this code right here, this is going to keep reading the numbers properly, but we are not doing anything with the numbers yet. But this is how to read the numbers. So then it says we we're trying to find the lowest number that's read. So that's finding the minimum, right? And we've covered the minimum on more than once, I think. And the way you do it is you create a variable for the minimum. I'll call it min. And when you're doing this for an array, you make the minimum equal to the first number from the array, right? In this case, we don't have an array. So I'm just going to make the minimum equal to the number that we just read. And then here in our loop, what we want to do is we're going to compare the number to the minimum. So if the number that we just read is less than the minimum, then that means it's our new minimum. So the minimum should be equal to the number. And then we should stop. And after we do that, we'll read a new number so that next time around, we'll be comparing a different number. And so now we're going to be calculating the minimum correctly. And then at the very end of this, we should just return the smallest number that we saw, which is what I call the min. So this is the same code that we've used multiple times for calculating minimums, just stuck into a method this time instead of just doing it for an array or something like that. All right, I think that's correct. I'm going to hit check and find out. And we got it. Okay, maybe one more. One more and then we'll stop. So define a method check vals with the scanner parameter. Okay, so that's going to be check vals with the scanner parameter. So I know I'm going to have a public static. I haven't found the return type yet. Check vals and a scanner input. All right, that part's done. And it says reads integers from input until we get a 1. So similar to the last one, we're going to start this by reading a number from the input to get us started. I wrote scanner.extent, but that should have been scnr. All right. And we're supposed to read until we get a 1. So similar to the last one, we'll be saying while the number in this case is not equal to 1, we keep going. 1 is what will stop the loop, right? So go until we get a 1. So that's very similar to how we started the last one. After we took care of that, it says check vals should return true if none of the integers read before the 1 are between -1,000 and 9,000 exclusive. Okay, none of them are in that range. Okay, what do we do? First of all, let's find a variable to store our answer. I'm just going to call it, result, okay? And typically, the way that you'll do this is it says we should return true if none of the integers read are between these values. So what I'll do is I will start this out as true. So we'll start the variable with a true in there. And then what we're going to do in our while loop is we will see if the number is in this range. So if the number is greater than negative 10,000, greater than or equal to 10,000, negative 10,000, and if the number is less than or equal to negative 9,000, then what? So we're supposed to be true if none of them are in that range. But if any of them are in this range, if any of them are in this range, then we should return false. So you could put return false here. That's one way to do it. I'm not going to do that. What I'm going to do is I'm going to say that the result is false, like that. And then I'm going to go to after my for loop, or after the loop, not a for loop, a while loop. Um, we will return whatever is in the result. So if if any of the numbers were in that range, then we're going to have a result as false. But if none of them are in this range, then we're still going to have the original true value that we put in there at the beginning. There's one more bug, not bug, but something I haven't done, which is we're reading a number here, but we also need to read a new number every time through the loop. So in your while loop, after that if statement, we read another number. That way, every time through the while loop, we get a new number to compare. Cool. Very similar structure to the one that we just did with the minimum, but we're not calculating a minimum. Uh-oh, did not compile. Why not? Invalid method declaration, return type required. Oh, yeah, I put question marks there. We were returning true and false, right? Which is a Boolean. All right, and it worked. Now, if I got this wrong, like if I put a false here and a true here, or something like that, you would have been able to tell that you got it backwards because you would have looked down here and like every one of these would have been wrong. And if they were all wrong, that would tell you that you switched around the true and the false or something like that. It is really easy to get these backwards, but we managed to do it here. Okay. And if you read the kind of instructions that it gave us, you'll see that these instructions are match up exactly what we did, right? Read val from input. I called it number. Use a while loop that iterates while val not equals 1. So um, while the number is not equal 1. And then if val greater than or equal to 10,000 and val less than or equal to negative 9,000 is true, return false. So they did return false here. I said the result is false. And they said return true after the while loop terminates. They were trying to teach us something here by this. So I have a variable that's storing the result, and then I return the result at the end. That was not necessary. I could have skipped this and not had the result. What I could have done is whenever I see something that was going to make it false, I could immediately return false. And then after the loop, you just say, instead of return the result, you would just return true. And so what happens here is in your while loop, if you ever see something that would make you return false, you return false. And if you return, that means the method ended. And so if the method ends in the highlighted code, then we never get to the return true on line 16. So return means your method ends. So if you get here, then we did not return false, right? So in the highlighted code, that's where we would have returned false. So if you even manage to get here, then the answer must be true. And so doing that, then you don't need to store a variable. You don't need to keep track of a variable that's true and false. You only need to say return true and return false. All right, that would have worked the exact same, and that is what they suggest here in their explanation. All right, so that was this lecture, covers significant amount of chapter 12. The next lecture is probably going to mostly cover stuff that is going to be relevant next week, but still might be useful for you now. All right, I'm going to stop this and I will talk to you guys later.